And then this, there's your 90. We got our A, B, and C labeled. Use Pythagorean theorem, you find that's 121. And then the question is, what's the shortest option? One lap around the perimeter. Lots of you were able to successfully add that up. 110 and 110 is 220, plus 100 is, so you did the 110 plus 110 plus 50 plus 50 is 320 meters for one lap, or 3 times the diagonal. 3 times 121 is 363. So which is shorter? One lap. To those of you who successfully completed that, congratulations. Flip the page. Mr. Easton's buying a TV. You would have found that the height, or you should have found that the height of the TV is 45. That should be inches, not meters, because that would be a massive TV. So the answer is no. Mr. Easton will not be able to fit that television into his car.
What if you lay it down flat?
It didn't specify which direction that it fit 40 inches. So, you know what? This is a conversation you can go have with Mr. Easton. I don't know how he was arranging it in his car. And actually, I know what kind of car Mr. Easton drives. He would absolutely be able to, in the real world, absolutely be able to fit a 40-inch TV in his car. He drives a RAV4 with a car seat, so which means that the rest of the seats can go all the way down. So he would absolutely be able, in the real world, Mr. Easton could fit this in his car. But in my imaginary math world, where he can only fit a 40-inch TV in his car, the answer is no. But Mr. Easton has since got a new car. He could totally do it, actually. Then Gurman is flying a kite. The string goes from the person to the kite. And we know from the question is that Gurman and Jacob are standing 40 meters away from each other. So this is the problem you're trying to solve. This is roughly 51 meters, give or take half a meter, depending on what you got. This is what you were looking for. The height of the kite is 51 meters. And then last but not least, you have Taylor, who leaves her house walking to school. She walks 20 meters west and 125 meters north. How far away is she from her home? So she moves, and I even put a little compass on here for you. She moves 200 west. She moves 125 north. You wanted to find the distance from where she is now back to her home. This distance here is 236 meters. Would any of you like me to do any of those questions in full detail? Doing all of the math. Dakota says no. Does anyone disagree with Dakota? Does anyone want to see any of these questions? Ethan also says no. Hassan looks kind of shifty. Dakota's looking at Hassan like, you keep your mouth shut, boy. Okay, so that's it. If there are no questions, then we are done. Well, Ethan, I'm going to give you a review pack. Perhaps your note pack might be useful when doing the review. You do have to do the review. Because if you recall, Ethan, about 10 minutes ago, you said, are we going to do the rules? And I said, yes. And you said, I'm so screwed. So,
I said there's hour time.
yes. So if you're sitting there feeling like, if this is what the test is on, you're so screwed, then perhaps the review and your note pack to do the review might be useful. So,
How many more quizzes are going to be until the end of the semester?
so many quizzes.
Actually, so do I have a chance to fail in your pass?
You will have lots of opportunity. And then there's a final exam at the end.
Do you think I'm going to fail that?
based on whether or not you choose to give up. If you're like, I'm going to give up, well then I don't see you having a ton of success. But if you're like, no, I'm going to prove you lead off wrong, screw that guy. Ooh, and you work really hard, then you'll be great. And sometimes getting after your teacher is a phenomenal motivator. I once had a teacher at university who, Ethan, I don't know if I told you the story, but I did that thing where you try to hand in the assignment. Maybe you've done this, where you're like, people are handing the assignment on the desk and you're embarrassed about yours. So you try and slide it into the middle of the pile. Yeah, so I did that. And he saw me. I was like, there's only 12 kids in the class, so of course it wasn't easy. It was hard to hide that. So I slid it in there. And he dug through and he pulled it out. He said, "Read off this is shit." He threw it in from across the class and the table and everywhere. I was like, you know what?
Did you tell us that?
Maybe I did. I don't know, but he can hear the story yet. I was like, you know what? Screw you, Jeff. And I used my anger at being humiliated a little bit to, I used it to really improve my grade in that class. So that is a way you can use, you know, that kind of thing to motivate you. I'm not going to forget. This is how we end class.
No.
No. The candies are the prizes for these.
Ah.
How are you reading?
I have good news. I do. Tuesdays and Thursdays.
Oh, we get a blow punch up on Tuesday.
Okay.
Yo.
Yeah. They are here somewhere. Okay.
That's fun. Yeah.
Okay. Perfect. Yeah, the library one. Okay, so. No, you may not pay me in chocolate to not do this. I do like coffee crisps. Okay, so before you get started, I am going to, we are going to discuss this front page together, and for this chapter test you guys are going to make on Thursday, I will give you I will allow you to use your version of this front page. So, I'm going to go through it here with you. Whatever you write down or choose not to write down of what we're going through right now will be what you have access to on Thursday. So if you choose to leave it blank, well, that's so sad, too bad. If you choose to use what I write down here, then we'll be good. Then your life will be made easier, almost certainly.
What do you mean too bad, so sad if I don't write it?
If you like sit there with your arms crossed from here on out, and you're like, I'm not going to write any of this down, on Thursday when you come to the test and I say, everyone, get your this page out, and you're like, oh, mine's blank. Well, tough luck.
Oh, I thought you were going to be like, you have to do this first for the quiz. That's not great.
No, you won't be allowed to use this as a cheat sheet on the test, is what I'm telling you.
Yeah, that's fine.
Okay, so that's entirely your call.
Yeah.
Here we go. So, just to review, and we're going to have a couple days to review this. There's a lot of questions in here, but there's also answer keys and all sorts of solutions in here. So, this is a useful tool for you to prepare for this test on Thursday. The exponent rules. There were 6 of them we went through, and this is the order we did them in. We started with the product rule for multiplying same basis. Product is the result you get when things get multiplied together. And if you recall, so I'm going to give you all my reasoning here. In the first one, if I had 2 cubed times 2 squared, now what does it mean to cube something? What does that mean? Yes, Dakota. Yes, times it by itself 3 times. So 2 cubed is going to be 2 times 2 times 2. That's this first piece here. Don't go to 8 yet. Don't do it. Don't do it. And to that, 2 times 2 times 2, we are going to multiply something in there. Actually, I'm going to zoom this in so it's a little bit easier for all y'all to see. We're multiplying 2 cubed by 2 squared. 2 squared is 2 times 2. So what we had here was we have, instead of having 2 cubed times 2 squared, what I actually have here is 5 2's multiplied together. See, look, 1, 2, 3, 4, 5. Don't go to 32. We don't want to go to 32. That takes away from the rules that I'm trying to teach you here. So, because, Harsh, what I want you to see is that if I have 2 cubed times 2 squared, that's the same as having 5 2's multiplied together. So using our exponent notation, I could rewrite this thing as 2 to the power of 5. Yes, Harsh, this does happen to equal 32.
Oh, I was going to say that.
Well, so many people have said it already, so that wouldn't have been, overly profound. This is standard or evaluated this is power form, or writing things as a power. And what I'm trying to get you to see here is that this first exponent law, one of the most useful of all of them, tells us that when we multiply the same base together, what can we do with the exponents? Well, I got 2 cubed and 2 squared gave me 2 to the 5. How do I go from 3 and 2 to make 5? Dakota, you can add exponents. When the bases are the same and you're multiplying them, you add the exponents together. So when bases are the same and you're multiplying, we add the exponents together. So if I have x to the 3 times x squared, that's going to be x to the 3 plus 2, which is x to the 5. While we're here, let's talk about these pieces here too. That 2 is what portion of the power? Like what do we call the 2? Yes, who said that? Jared, was that you? This 2, just to make sure we all have the same language here, that 2 is called the base. The 3 is called the what? The exponent. There we go. So we got all these pieces here labeled. So if I apply the rule then to some of these, if I have 5 to the 4 times 5 to the 6, it's going to be what? 5 to the 10. If I have a to the 4, a to the times a to the 6 times a to the 5, I'm multiplying all those bases together, applying the rule, that's going to give me what? Yes, someone said it, a to the power of 15. Well, Ethan was yawning. And in this last one, hello Ava, if I have negative 3 squared times negative 3 to the 6, that's going to be what to the power, sorry, one more time, Jared? I have negative 3 squared times negative 3 to the 6. The base needs to be written exactly as the base is. I'm still going to have my negative 3 in brackets. Dakota, it's going to be 8. 6 plus 2 is 8. You it is true that negative 3 squared is negative 3 times negative 3, which is 9. That's not the point. What I want you guys to be able to recognize is this is how these exponents behave, and we can condense these things to being a single base with a single power. Now we can evaluate these things. You guys are going to have calculators for these. I won't expect you excuse me, to evaluate any of these without a calculator. But for the sake of this, I'm going to leave this column blank right now. Okay, so that's the product rule. The next one we looked at was the quotient rule. A quotient means we're dividing. Yes, Jared, you are right. When bases are the same and we are dividing, we subtract exponents. Let's prove it. Take a look at what we've got here. If I've got 2 to the power of 6 divided by 2 to the power of 3, I can rewrite this thing as 1, 2, 3, 4, 5, 6. I have 6 2's multiplied together. And I'm going to divide that by 3 2's multiplied together. I'm just going to change the notation, rewrite the thing as a fraction. And when we're multiplying and dividing, if that's all we're doing, we can do that in whatever order we want. So 2 divided by 2 is 1. This cancels away. 2 divided by 2 is 1. Those pair cancel away. 2 divided by 2 is 1. And those cancel away, leaving me with how many 2's left over multiplied together? 3 of them. So this is the same thing as 2 times 2 times 2. We'll add in another equal sign here. So that's 2 to the power of 3. That was the long way that I tried to justify with you guys how this rule works. And if you look here, I can make this argument. Well, I've got 2 to the 6 divided by 2 cubed, and I end with 2 to the 3. How can I use 6 and 3 to get 3? Dakota said it before, or Jared said it before, Dakota said it now. We can subtract. So then in general, it doesn't matter if it's written as a fraction or if it's written with the division notation. When you're subtracting the exponents, you always go left to right or top to bottom. This is going to be 6 minus 3. So that'll give you x to the 3. We can crank a couple of these examples out for you right away. If I've got 8 to the 10 divided by 8 to the 5, it's going to be 8 to the power of. Because we're dividing, we subtract first minus second. 10 minus 5 is? 5.
Who said 5? It's 2.
It's not 2, it's 5.
What?
When you divide bases, Jordan, look here. Ethan, don't mess around. When we're dividing bases, Jordan, we subtract the exponents. When we're dividing bases, you subtract the exponents 10 and 5. 10 minus 5 is 5. Which part? This part? Or this part?
Dividing something.
We're dividing, hold on. But what are we dividing? We're dividing the bases. We have 8 to the power, like look here. I had 2 to the 6 divided by 2 cubed. So I had 6 2's on top. I had 3 2's on bottom. And we're able to cancel out pairs of 2's. Are you cool with that? Jordan? You follow what I did there? The brain. Okay, well, I'm just going to keep going. We'll catch your brain up on the way. So what's this guy going to be? 5 to the 6 over 5 squared? Nice. Jared says it's 5 to the 4. Jared's correct. And this last one, I've got a combination of multiplication and division. What am I going to do with the 2 and the 7? I'm going to add those two. And then what am I going to do with this 3 here at the end? I'm going to subtract that one. So we're going to have Ethan, if you're just messing around, please don't try and confuse other people. 2 plus 7 is 9, minus 3 is 6. Nice. So these are the two most important rules. Again, we could have you evaluate them. The evaluating portion is where you shove it into your calculator. We'll save that for later. Man, Jared's got them all memorized. When you have a power to a power, so I've got 5 cubed squared, we're going to rewrite that as 5 to the power of 3 times 5 to the power of 3, because that's what it means to square something. It means to multiply it by itself twice. If I take a look here, I can rewrite this as 5 times 5 times 5, that's the first one, times 5 times 5 times 5, that's the second 3. So this would be 5 to the power of how many 5s are multiplied there? There's 6 of them. So how could I go back and use 3 and 2 to get 6? Yeah, as Jared said before and as Dakota said now, when you have a power to a power, you multiply these two things together. So powers raised to an exponent, you multiply the exponents, multiply. So this is going to be x to the 3 times 2, which is x to the 6. Fantastic. So this first one's going to then be 3 to the power of 10. This one's going to be negative 3 in brackets to the power of what? 12. Oh, and then we've got a lot going on here with the b's. We've got a few rules going on here. We've got a power to a power. We're multiplying and we're dividing. So what am I going to do here? Take a look at what I'm circling. If I have b squared to the 3, that's the same as b to the 6. I multiply these two together. We multiply here. And then what am I going to do with this guy? Because we're multiplying then this b to the squared here. This exponent's, yes, this exponent's going to get added, you bet. And then this guy down here is going to get, this 3 down here is going to get taken away, you betcha. So if I write all of that in one big chunk, we're going to get b to the 2 times 3. We're going to add the 2 and take away the 3. All of those pieces going on here kind of all at once. So I think someone said it already, 2 times 3 is 6, plus 2 is, 6 plus 2 is?
Oh, 8.
You betcha, minus 3 is?
This 7.
No.
Wait, 6.
8 minus 3?
Oh. 5.
You betcha. Yeah, when the train of thought derails, that's never fun. Okay, 3 done, 3 more. Here we go. So here I've got 2 times 3 squared, all cubed. So let us rewrite this thing. Cubing something means to multiply it by itself. So, multiply it by itself 3 times. Hassan, we good? Okay. So this is going to be 2 times 3 squared times 2 times 3 squared times 2 times 3 squared. So how many 2's do I have multiplied together here? Don't tell me the answer is 8, even though that's true. We want to use exponent laws. 2 times 2 times 2 can be written as 2 to the, it's always the base, the thing that's getting multiplied. 2 to the 3, you betcha. 2 to the power of 3. Because there's 1, 2, 3 2's being multiplied together. And how many 3's do I have here? Well, I've got 2 here, 2 here, and 2 here. Careful. I've got 2 3's, 2 more 3's, and 2 more 3's. Because that's what these exponents mean, right? Each one of these exponents means I have 2 of the thing that's to the power. So that's 6 total, you betcha. Well, what have we done here? If we take a look at this question, if I have 2 times 3 all squared, and I'm ending up with 2 to the 3 and 3 to the 6, well, what happened? What happened was this exponent on the outside, excuse me, gets applied to everything on the inside. And where there is an exponent already, we use the previous law and we multiply them together. So when you have a bunch of multiplication going on inside, the outer exponent goes onto each piece, and where there is an exponent already, they get multiplied together. So then this guy here, you know what, well, let's do the words first. When we distribute the outside exponent to all exponents inside by multiplying to all exponents. Sharing is caring, in fact. And it's kindness week, so that's useful. Yes, Hassan. No. As soon as I got this, and then you can go. Okay, so I got something like this. I have 2xy cubed. The mistake that I often see is that we forget the 2. This is all multiplied together. So we need to make sure that that 3 ends up going on to each piece being multiplied there. So that's going to give us 2 cubed, x cubed, y to the power of 9. You bet. So then let's be careful here with how we use these with the minus signs. This thing, this squared, is going to go onto each piece being multiplied here. So we need to make sure that we write that -3 with brackets around it to make sure that that negative is included there. That's going to be squared times 2 squared. This guy needs to have that 3 on each piece. We're going to have 3 cubed, x cubed, y cubed. Gentlemen, what are you doing? Okay, so that's, I hope not there, and I hope not with that phone. That would be gross. He was standing in the hallway taking pictures, and he said he was going to the bathroom. That would be gross.
Oh.
See what I did there? Yeah. Okay, so this last example here, we've got a 5 multiplied on the outside. Because it's on the outside, the exponent does not go onto it, just what's on the inside. So this 3 goes onto the 2, the x, and the y, not onto the 5. The 5 stays where it is. The 2 becomes cubed. The x becomes to the power of 6. We multiply them together, good. And then y to the power of 3. That 3 just goes on to what's inside the brackets. And we'll leave the evaluating for later. Okay, 2 more rules. I know we're going quick. Bless you. When I've got a fraction, cubing something, Ethan and Hassan, you can make your deals later.
Yeah.
When I'm cubing something, it means to multiply it by itself this many times. So it's 3 over 4 times 3 over 4 times 3 over 4. How do I multiply fractions? Yeah, but what do I do? Yes, I go across the top, Dakota, and then I multiply across the bottom. So 3 times 3 times 3, yes, it's 27. Don't tell me that it's 27. We're using exponents. If I have 3 3's multiplied together, that's going to be 3 to the power of, don't tell me it's 27. It's going to be 3 cubed. No, it would be 27. 3 times 3 is 9 times 3 is 27. Don't do that, though. I want you to write it as 3 cubed over 4 times 4 times 4 is 3 4's multiplied together.
16.
Nope, that would actually be 64, but we're going to leave it as 4 cubed. The whole point is, I want you to leave it as the exponent laws.
I even give you 8 times 8.
Nope, 4 times 4 is 16, times 4 is 64. Okay, so how does this actually play out? The exponent on the outside goes into the numerator and the denominator. X cubed over y cubed. So we distribute the outside exponent to all exponents inside by multiplying exponents top and bottom of the fraction. Bless you. So then, what's this one going to be? Don't tell me it's going to be 8 over 81 or 16 over 81, even though that's true. Yes, Dakota. Yep, that's all I want. 2 to the 4 over 3 to the 4. Nice and easy. B and C get more interesting because we're going to bring in other exponent laws here too. When I've got a fraction, it goes onto the numerator and to the denominator. And when I have things multiplied together in my numerator, it has to go onto each of those pieces. So it's going to go there, there, and there. Hassan, you're writing all this down, right? This is going to be a cheat sheet for you on your guys' test. 2 cubed times 3 cubed all over 5 cubed. And then the last piece here is the same. This 5 is going to go onto each of these pieces. These now, though, have exponents already. So when you've got a power to a power, we multiply. So this one's going to be 2 to the power of a to the power of over b to the power of, you bet. Now things are getting more interesting. Last but least, we had one more rule. Almost anything to the power of 0 is? Jared, I see that finger. If it's written like this, if I have 1 to the 0, anything to the power, almost anything to the power of 0 is 1. The only exception is if I have a minus sign out front written like this. If I had this, if I had -1 in brackets, put that in the middle there, a -1 in brackets there. If this is to the power of 0, this is still going to equal 1. I'm too excited, my voice is giving it. But when it's written like this, if there is no exponent there, the negative isn't included as part of the exponent. Sorry, the negative is not included as part of the base. So you'd have 1 to the 0, which is 1, multiplied by that negative out front. This, it's going to be -1. If the negative sign's inside the brackets, it becomes positive. If it's not, it stays negative. So x to the 0 is 1. Take a look at these three here. 15 to the 0 is going to be?
15.
Nope. 1. This one with no brackets, -x to the 0 is?
-1.
Thank you, Jordan. When there are no brackets, that negative stays.
1.
And this last one here is going to be 1. Very good. Okay. For those of you who filled out this page, you will be allowed to use it on your chapter test on Thursday. If you chose to not, and you have no good reason to leave it blank, I will not be providing you with a copy of this. So, that's it. That's all I'm going to do today. The rest of this is for you guys to practice at whatever speed you're going to go through it over 30 seconds. I want to show you some pieces to this. There's answer keys for you. It says solutions, and then it gives you answers as you're working through. Same thing here. Solutions as you're working through. Flip the page. There's some BEDMAS questions here with solutions. This section right here, where it says to estimate, it says estimation of square roots, skip. We didn't do it. We're not going to do it. You can cross that off as vigorously as you would like, just these top two rectangles. Don't worry about that part. We're skipping it. The bed mass with roots, solutions. The Pythagorean theorem, solutions. Word problems, applications with the Pythagorean theorem, solutions. And then you get to this page where it says exponent laws applications 1. If you take a look there, there's like 30 questions, 24 questions, and then answers. And then there's another one, exponent laws application. Another 24 questions and solutions. Okay? You're going to have the rest of class today, Tuesday and Wednesday, to work through this with myself, Miss S, and on God. Thursday is your guys' chapter test. Hassan needs to go to the bathroom, so I'm done.